after having looked at the budget constraint, now we're going to look at how how economists view an individual's choice of where to be or what they're going to do. So we're going to look at now how they optimize their objective function. So we have this example here where the nephew can purchase, I think, Timbits at 50 cents each. McNuggets are $1 each. I've got the budget constraint. We're going to give him $30. You can see it here. $30 is here. And I'm going to start with the choices that the person could have made. So let's say, for just the sake of argument, that my nephew chooses bundle B, which means that he happens to pick 40 Timbits and 10 McNuggets. So he's going to be on the budget constraint. We're going to spend all $30. Now, because he chose this, and this is what we mean by revealed preference, he could have selected point C, for example, but he didn't, because he chose to spend all the money. But more than that, we can say also he could have chosen any other point on the budget constraint. And so as a result, we can conclude that bundle B is definitely better than any bundle C. That includes all the ones on the budget constraint. We can say that B must be better than any of the bundles C. Now, what about things that are possibly better than B? Well, the general assumption is that anything more is better. So by that, we say, recall that he's chosen bundle B. He could have chosen C. He didn't. But bundle A offers more Timbits and more McNuggets, so we would say A is better than B, but of course he can't choose A because he doesn't have enough money for it. Now, we can go further than this. We can say anything that gives him more Timbits but just as many McNuggets is also better. So anything in A is better than B. He would choose it if he could, but he doesn't have the money, he can't. So we can refer now to two zones, if you will, Zone A and Zone C. Zone A includes the black lines, and Zone C includes the budget constraint. B is definitely better than anything in Zone C, and anything in Zone A is definitely better than B. Where the problem arises is pick a bundle like Z1, for example, or Z2, we don't know. We don't know whether he would prefer, given the choice between a bundle B and Z1 or bundle B and Z2, we don't know. Because in the case of Z2, he's going to get more Timbits, but he would get fewer McNuggets. And so it depends on the individual, whether they'd be willing to make that trade-off or not. So we're going to take a look at this idea a little bit further. This brownish zone is what we call the don't know zone or can't say zone until the person has revealed their preference for a choice between the two. Let's consider a possibility. Let's take Z1 as a possible bundle. Now, in this case, he's going to give up a few Timbits, but he's going to get quite a few more McNuggets. So for the sake of argument, let's just say he thinks that he would prefer Z1 if he could. He doesn't have the money for it, but if he could, he would choose Z1 versus B. So we can say that Z1 is really in the A zone. Similarly, we might choose another bundle like, I don't know, this one here, Z2, in which he's giving up, quite a few Timbits, but he gets McNuggets. And let's say, for the sake of argument, that between Z2 and B, he would prefer B. Again, Z2 is not a possibility. He's beyond his ability to buy it, but if he were given the choice, he would still choose B. So we can sort of say that Z2 is like in the C zone. What we hypothesize in economics is that there's some kind of a line that would go through this brown area that would become the border between Zone A and Zone C. This line has a name, and it's referred to as the indifference curve. What we mean by that, not only is it the border between what is good and what is worse, compared to B, let's say, but also means that anything along this purple line, the person can't decide whether they want B or B3 or B1 or B2. These are all comparable. So now what we can say is Zone A is the area above the indifference curve, and the worst zone C is everything below it. Anything along the indifference curve, the individual can't decide between one or the other. There are 4 general rules for indifference curves. I'll go through them. First of all, more is better. That means there is no such thing as what's called a bliss point. A bliss point means that a point like this here, where a person simply doesn't want more Timbits or more McNuggets. So the general concept here is more is always better. Second, draw it this way, better being going to the upper right-hand side, worse being lower left, towards the origin. The indifference curves always have a negative slope. The logic here is that in order to, an individual, in order to accept giving up something like Timbits, we have to offer the person more of the other thing, McNuggets, let's say. Now, that trade-off, the slope of the indifference curve, is going to depend on the individual. This also means, identically, is that indifference curves are bowed to they're convex, the technical term, convex to the origin. They have this particular shape. Other critical point is that indifference curves never cross. They can't. In simple terms, you could imagine a point like this here and this point down here. Well, the person would be indifferent between them, call this B1, and this one over here B2. But then we'd have another indifference going up this way where potentially the person could be B3, and this would violate the idea that more is better. So indifference curves would never cross. In actual fact, what it amounts to is it's really a 3-dimensional object. We've got the 2 dimensions here, and then utility is on the 3rd dimension rising upwards. Now, what determines the shape of an indifference curve? This is the preferences of the individual. Sometimes this is referred to as consumer sovereignty. Consumer sovereignty actually means a little bit something more, but we can sort of understand that each individual has their own preferences or tastes or things that they like between 2 different goods. The modern term for this might be something like orientation. People are born with this. Now, keep in mind, too, that there's many things that we haven't tasted or you don't know, so you haven't decided yet whether you prefer them or how much you'd be willing to give up to get something else. And in the process of doing that, well, you have to experiment and try and test. And having friends, somebody might explain something like advertising, provide you information about whether you like something. Think of something like picking a movie to see. Until you've seen the movie, you don't quite know whether you like it or you don't like it. But other basic things like being vegetarian or eating meat or different types of taste, this is what we mean really by the technical term for this is preferences or tastes, and ultimately we mean the utility function or the shape of the indifference curve. So it's up to each individual how they would want to be shaped. What we can say about the shapes is, generally speaking, if they're flat like these ones, we mean that a person is willing to give up good Y to get good X. It's a bit like saying if I think of Pepsi and Coke as being very similar to one another, then I'd be quite willing to say, oh, I'll take a can of Coke, I'll take a can of Pepsi. And so indifference curves of that shape sort of look like the ones we're looking at here. This means somebody's willing to accept a trade-off between the two. At the extreme, we could say they're completely flat, which means to say, notice they're no longer convex to the origin. This would be an extreme case, but they're perfect substitutes. In this case, a person would be willing to easily make a trade-off between them. Like, for example, gasoline. Someone might say Shell, Esso, same diff, doesn't matter. In this case, the price will make and we'll see later, the decision to purchase something will be based purely on the price. Another extreme case are goods where somebody says, I'm not willing to make up any kind of substitution. We refer to these as perfect complements. Again, we're going to look at this term later, but the basic idea here is 2 goods would be like saying, well, if I've got a computer, I need a keyboard, and there's no point in having a second keyboard because I won't be able to attach it to my computer. Or hot dogs. These are classic cases, hot dogs and hot dog buns. I'm not willing to trade off a hot dog bun to get another hot dog, because what am I going to do with it? So in this case, we refer to these as complements, and this is the shape of the indifference curves. They're kinked is another term. It leads to mathematical problems, but this is another extreme case. It depends on the goods and it depends on the individual, but in principle, we look at something like this and say this is a person who's not flexible, stubborn. They're not willing to accept a trade-off from one good to another. Another very important point to refer to is the slope of the indifference curve. Another term for this is known as the marginal rate of substitution, or just the MRS. This refers to the willingness of a person to give up something to get something else. And so, again, it depends on the individual. But the amount you'd be willing to give up to get something else. And you'll notice something, too, about this, is that at this point up here, for example, when a person has a lot of good Y, they would be willing to give up quite a bit of it to get a little bit of the good X, because they don't have very much of good X. On the other hand, at a point down here, it would be the opposite. They'd be not willing to, they've got a lot of good X down here, but very little of good Y, and so in order to get them to accept in order to they'd be willing to give up a lot of X in order to get a little bit of Y. If you imagine going this direction here like this and then going up a little bit. This is an assumption about economists make about individuals. It may not be true. Each person is different, depends on the goods and so on, but this is a general assumption. And the term for this is the marginal rate of substitution. Maybe the important point is that the slope of the indifference curve is going to be different in different places. Last key point, this one we'll come back to later, is that when a person chooses their optimal point, where, for example, we had a moment ago, my nephew chose 40 Timbits and 10 McNuggets, the idea was that he would get to the highest indifference curve given the budget constraint, as we've seen here. Now, another indifference curve, he could have been there at, say, a point like this down here. He's got the means for it. He's on the budget constraint. But he could go to a higher indifference curve, be higher at the one that's indicated as U optimal. He could go to a still higher one, the indifference curve unattainable, but he doesn't have enough money for it. Now, at this particular point, though, let's call this B here again, the slope of his indifference curve, that's the U optimal one, the slope at point B of the indifference curve will just equal the slope of the budget constraint. It'll be tangent. That's a question of optimization. So this is a very important point, and we'll come back to it later when we start looking at what are referred to as the welfare implications of economic theory.